Okay, so now let's go and take a look at Extrema. So Extrema is basically going to be like the maxes and mins of a graph. And that's something we looked at the warm-up, like how high does the graph go, how low does it go? But there is a difference between the Extrema. So the first two is the absolute max and the absolute min. And that's going to be values that the graph cannot go any higher than or any lower than. Whereas relative maximins is like only maximins that occur within a given interval. So they're still maximum and minimums, but they're not the absolute highest point on the graph or the absolute lowest point on the graph. They're just going to be the higher or lower points within a given interval. So I think it's easiest to kind of like look at this just from a graph version, and therefore you can kind of, really, oh, okay, yeah, that makes sense. So for instance, let's kind of look at the absolute max. So if I, had a graph here, and you can see here that there's two kind of maximum points, right? We have this point and we have that point. Well, your absolute maximum point is going to occur right there because the graph does not go any higher than that absolute maximum point, right? So that's going to be your absolute max. As far as absolute min, it's like the exact same thing. However, it doesn't always have to be like a polynomial. We could look at like the square root function here, right? You can see like the absolute lowest point here is going to be right there, right? The graph does not go below that value. We can try to draw the exact same graph here for the absolute max or for the relative max, which is also called the local max. And the reason why it comes by that name, is we have our two maximum values. So this is a maximum point, but it's on a maximum point on an interval. And the way to kind of understand, again, maximum point is like looking all the values directly to the left as well as directly to the right. As long as that point is higher than the points to the left and to the right, it's a max. So you can see here, if we were to kind of create a interval, let's say the interval from here to here. And if we just zoomed in on that interval, and just look, all right, from this value to this value, right? Just zoom in, maybe make our graph just look just there. If you just zoom in on that local min or that local value or that local picture, you can see that that is a maximum point. So therefore it's called a relative max because it's relative to the whole graph. Obviously, as you zoom out, you can see that there is a higher point there, but when zoomed in, relative to the graph, that is a maximum value. And another one just for the min here is sometimes we could look at something like, let me draw an XY axis. Okay, this is again is a relative min here. So you zoom in here, you could say, all right, points to the left as well as points to the right, this graph is higher than, right? So our relative min occurs at that value. Even though that's not the lowest point, because you can see that the graph continues going down indefinitely, right? So it's going to continue going lower and lower. This is never going to be the absolute minimum, but you can see within my little box here that is a minimum value. Now, it also is kind of important to talk about these, that when we're talking about the max and mins, just make sure you understand what the question is, because it says where does the max or min occur, then we're going to be looking at the x value, right? The min occurs at x equals, or the max occurs at x equals. If the question is asking about the value of the max or min, then they're looking for the y value. So just make sure you understand the question, because a lot of times people get something wrong if we say where does it occur, and then they use the y value, or they say what is the value of the max, and they're using the x value. So just make sure that you understand the question and therefore you respond appropriately. All right, so the next one, our next kind of characteristic that goes right in step with this is bounded. And bounded is basically just means when a bounded above is basically means the graph does not go above a certain value, or bounded below is going to be when it doesn't go below a certain value. And we call a function bounded when it has a maximum as well as a minimum, and we call a function unbounded when it doesn't have a max or a min. So, we could look at all these. You could say that's bounded above, that's bounded below, that's bounded above, and that's not bounded. But let's just kind of look at some different examples here real quick, because I wrote some out that I wanted to do. Oh, did I already use? Oh, okay, well, either way. Let's just graph some more. Let's graph some fun ones. So we could do something like this. We could do another graph like a quadratic, right? So the quadratic, looks like here has that maximum point here. It doesn't go above that point, so that would be bounded above. We could also look at, let's say, we could look at one graph where maybe it's approaching a horizontal asymptote, right? So let's say this would be like the exponential function. It's not going to go below that horizontal asymptote, right? So therefore, it's bounded below. It doesn't go below. This doesn't have a absolute minimum, right? There is no point that's the smallest minimum, but you can see that it's bounded below the y value of y equals 0. We could also look at some crazy graph, something that maybe like oscillates, which we'll talk about later in this chapter. But you can see if it if it's bouncing between the max and the mins, you can see that this graph is bounded, right? It has a max and it has a min, which is not going above or below at all. And even if it continues in both directions, it's going to follow the same pattern. So that's an example of unbounded or bounded. And then we can look at it like an unbounded, would just be one like, let's just do a line, right? The graph has no minimum and has no maximum. It's continuing going up in both of those directions. So, looking at arrows is sometimes helpful to kind of see where the graph is continuing, but also just kind of understanding the characteristics of them. Like, for instance, knowing where there's a horizontal asymptote, and then also noticing maybe there's no arrows, but noticing that there's the max and the min and so on and so forth. So that's kind of like our basic understanding here of our extrema as well as identifying the boundness of functions.